I'm going to show you how to rationalize the denominator, and I'll do several examples. So the big idea here with rationalizing the denominator is we are going to replace this radical, which is some decimal, it's about 1.4. We're going to rewrite it so that it is an integer, just a nice simple number. And here is how you do it. So if I multiply the denominator by the square root of 2, I would get square root of 2 times square root of 2, which would be square root of 4, and that simplifies to 2. And that was our goal, is to have an integer down there instead of an irrational number. So we have a rational number. Now, here though, I can't just simply go ahead and multiply the denominator by something, because that would change my original fraction. So I need to keep the same value there, and the only way to do that is to multiply by 1, but anything divided by itself is just 1. And so this is a very well chosen 1. Square root of 2 over square root of 2 is just 1. So 1 times that original number is still the original number. Okay, so then I would get in the numerator 1 times square root of 2, which is just square root of 2. And so my answer is square root of 2 over 2, and that is done. That's called rationalizing the denominator. And why, you might wonder, would we want to do that? Well, back before we had calculators, it was easier to do this problem if you take the square root of 2, and people had that memorized, so they knew that's about 1.4, and dividing that by 2 is an easier problem than taking 1 and dividing it by square root of 2. So but now that we have calculators, we don't really care so much about making our division easier. But what is useful is to understand and be able to see that these two numbers are actually the same type of fraction, and we could add those together. So it's going to be really useful as we go on in math to be able to combine fractions, and so we want to have this, the same number in the denominator of our fractions. So let's do a couple more examples. Next, I'm going to take the square root of 3/2. All right, with fractions, I can separate that as the square root of 3 divided by the square root of 2. We've got a little irrational number down here in the denominator, so I'm going to multiply it by square root of 2. Whatever I do to the denominator, I need to do in the numerator, so that becomes square root of 6 all over square root of 4, which would just simplify to 2. Okay, next one. Let's see, we've got square root of 9/5. I'm going to separate that as square root of 9 divided by square root of 5, and then I'll rationalize it. So I'm going to multiply by square root of 5 divided by square root of 5. And then we can simplify this, the square root of 9, that is 3, and then that's being multiplied times 5 in the numerator. And the denominator, we would have square root of 5 times 5 is the square root of 25, and that is just 5. So that one's done. Okay, I'm going to do another example. So here we've got 3 divided by 2 times the square root of 6. And so I'm going to rationalize the denominator. I'm going to multiply by square root of 6 over square root of 6. And now my numerator becomes 3 times the square root of 6. And then I would have in my denominator, I would have 2 times the square root of 36. And that just becomes, square root of 36 is just 6. So it would be 2 times 6, which is 12. And now I'm not quite done, because these numbers, 3/12, that can be simplified. So I'm going to divide both the numerator and denominator by 3, and I'll get square root of 6 over 4. When I'm dividing 3 by 3, I would get 1, and we don't need to write that coefficient of 1, so usually we don't write that. And then if I had 12 divided by 3, that would be my 4. So that's how I would get square root of 6 over 4. And that's done. All right, my last example, we've got square root of 11/45. So I'm going to separate this into square root of 11 divided by square root of 45. And then 45, I could rewrite that as 9 times 5. And then I could take the square root of 9 separately and take the square root of 5. So the square root of 9, that'll just simplify to 3. So that's not our problem. It's the 5, the square root of 5. So to rationalize it, really all I need to worry about is square root of 5. So my numerator would become square root of 11 times 5, so that's 55. And then I'm taking the square root of 9, which is 3. And then the square root of 5 times 5 would be the square root of 25, which is 5. So the denominator becomes 3 times 5, which is 15. So the final answer there is the square root of 55 divided by 15, and that is done.